Section 8.4, functions and their graphs. When we are graphing functions, what we are doing is finding the set of all ordered pairs that satisfy the equation. What graphs are pictorial representations of the equation. So they are useful because they give us a picture of what the function is going to be. So we are now told to graph the function f of x equals the absolute value of x plus 1. Use a table of values. So in our table of values, previously we would have done x and then y, but we've kind of grown up, we've matured, and instead of using a y, we use function notation, f of x, and then we have our work. But f of x, really it means the same thing as the y, it's just a more mathematical notation. So we have absolute value of x plus 1. If you remember, we want to pick 5 points, and there's no number inside the absolute value with the x, so we're just going to center our values around 0, and then I would just put in -2, which is 2 plus 1, so that's 3, and so on. You might not even need to show work for this one. It's 1 plus 1, 2 plus 1. All right, and so we have our points to plot. All right, so then we get out a piece of graph paper. And we plot our points. Oops, not there, up here. And we have one of those V-shaped graphs. Just a reminder, every absolute value is going to end up being a V-shaped graph. Other information that we need to know about functions and their graphs. When we're talking about domain from a graph, we're looking still at the set of all inputs, which is the x's, but we're looking at the x values that are covered by the graph. And the range, it's still defined as the outputs, but it's the y values that are covered by the graph. And we'll look at a picture of a graph here in just a minute. When we write domain and range, we use interval notation. Now, interval notation you may or may not have used before. So I have some rules for interval notation. The first rule is that you're going to use parentheses whenever you have a strict inequality, less than or greater than. You're going to use brackets when you have the or equal to inequalities, less than or equal to, greater than or equal to. You're always going to order your numbers from smallest to largest. You're going to join multiple sets with a union symbol, which kind of looks like a capital U. It's not a capital U, but it looks kind of like one. And then whenever we use infinity, it's always going to get a parenthesis. And by the way, the infinity symbol, it looks like a sideways 8. Also, when we are looking at a graph, we may be asked to find function values. Function values are found by finding the y value that corresponds to the given x value or vice versa. So basically finding the other coordinate in the ordered pair. And zeros of a function are the x-intercepts, which is also where f of x equals 0. Get my page turned here. Go. So next example, determine the domain and range of the function and identify any intercepts. For the domain, I mentioned how it's the x values that are covered by the graph. And so I'm going kind of from left to right across the graph. And if I even pick, points that are farther out than it looks like the graph is, like -8, if I think about it, this graph is continuing to go up and to expand. And so if I traced far enough, eventually -8 on the x-axis would reach the graph. And so would -10, and so would -20, and I could keep going to the left. Obviously here in the middle we see how 0 hits the graph, and 1 hits the graph, and 3 hits the graph. But just like going to the left, going to the right, I could pick points way out to the right, and if I went way up high enough, I would eventually hit the graph. And so what I'm trying to say here is that all of the x values that are possible are covered by the graph. So what we do for domain is -infinity to infinity. -infinity means it goes left the entire way. Positive infinity means it goes right the entire way. For the range, we're going to kind of run the same process, but with the y values. So if I pick a y value down here like -8, and if I go left and right, never will I hit the graph. Along the y-axis, the graph does not start until -4. But everything above -4 will always run into the graph if I go left and right. So our range, the graph starts at -4, then goes up forever. So we would put bracket on the -4 because the graph is on the -4, and then it goes up to infinity. All right, intercepts. The x-intercept is where the graph crosses over the x-axis. Those points are nice and clearly marked for me. And same thing, y-intercept, where the graph crosses the y-axis. Again, that's nice and marked for me. In our next example, so we have kind of a wavy graph here. This is modeling a boy on a swing. So you go up and back and up and back. That's what this is modeling. H is the distance above the ground over the time t. So it says, what are h of 2.5 and h of 5? Interpret these values. H of 2.5, so we are looking at the 2.5 is our, in this case, t value, what we normally call x. And when h of 2.5, when t is 2.5, the height is 8. And when the height is 5, no, not the height, when the time is 5, the height is 0. Interpreting these values, what this means is that he is 8 feet above ground at 2.5 seconds, and he is 0 feet, okay, so maybe not the best of swings, above ground at 5 seconds. Right, what is the domain of H? Well, we have the graph starting along the t-axis. We don't have any graph to the left. The graph starts at 0. The graph stops at 15. I guess after a few times of hitting the ground, because he's 0 feet off the ground, he decides to get off. The range, the y-axis, or the h-axis in this case, the lowest value is 0, the highest value is 8. Finally, for what values of h does h of t equal 8? So I'm looking for all the different times the height is 8. The height is 8 at 2.5 seconds, The next one, halfway between 5 and 10 is 7.5. And the last one is 12.5. We'll finish this section in the next video.